In this video, we're going to talk about Python strings. Okay, so strings are kind of in a weird place in Python. We use them as if they are a data type, like an integer or a double. And in some ways they are, but they're also a data structure. Okay, so if you look at python.org in the tutorial, it defines strings as immutable sequences of Unicode code points. Okay, so let's break that down a little bit. The big thing there, the big things, I think the most important things are that they're sequences, which means we can access the individual elements. Okay, we'll take a look at that in a second. But also they're immutable. Okay, so immutable doesn't mean you can't recreate the string with a whole new set of characters. You certainly can. What it means is that unlike a list where you can change a particular item, you can't do that on a string. Okay, so I've just started off here with some simple code here in PyCharm on how to declare strings. Okay, it can be either double quotes, single quotes, either one's okay. Or if you use triple quotes, you can do multi-line strings. Okay, and if you do so, the printout's a little bit funny because it takes all the characters in between. So I had to do it that way, and I think I've got that print out here, the S3. I think that will print it up in a line. So you sometimes have to play with it a little bit, but yeah, that kind of prints it lined up. Okay. So, so we have that. So let's talk about then what I mean that it's a data type. Okay, so I can say here, I can print S1 and I can index it at 0. Okay, and that should print out the first letter, the H, which it does. Okay, so we can access it that way. But what I can't do, I can't say that S sub 0 is equal to a capital H. Okay, this is going to throw an error. Okay, and the error is going to throw, oh, that's the wrong error. Change that to an S1. Now let's try it. Okay, now we get a different error. Okay, it tells us here that the string object, the str object, does not support the item assignment. Okay, so that's what we mean by immutable. Okay, so, but again, we can, if we want, I could change this. Okay, so immutable does not mean eternal, living forever. It means I can't replace it except by replacing the whole thing. I can't replace the parts. Okay, so that's perfectly okay. Okay, we can also create compound strings by concatenation. So I have a low here and there here. I could create a new variable, call it S4, being creative today, is equal to S1 plus S2. We're going to print S4, okay? And we see, oh, I didn't change it back to S2. So let me fix that. Okay, and you see that it does it quite literally. Okay, so if you want the look that you want, you would have to actually put in a space. Okay, so this quotes with nothing in it is a string, right? So I could put something, I could put in, you know, letters there if I wanted. That's a string. Okay, we'll call that a string literal. In case this case has a space, and these are named. These are variables that point to a string. Okay, or point to the string object. Okay, so we can do that. We can do repetition, which is kind of weird. So we can do something like ×3. I've always thought this was a kind of a weird feature of Python, but you can do that. Okay. We can do the index as we talked about. We can also do slices. And I've always found slices to be a little bit strange in Python, but at least they're consistent. Okay. So if we have our S2, okay, which has just the there in it, okay, I can, instead of a single index, I can do a slice. Like same thing we do with a range. So these slices always start with the value you really want to start with, but they end with one more than you think. So it goes up to, but not including. Okay. So let's say I do 1, that's where I want to start. And I want to print 1 and 2. Okay, I'll put a 3 here. Okay. And that should return an error. What doesn't it like? Oh, I need another closing parentheses. Okay. Okay, so that gives me the he. Okay, so again, it starts with 0. So I start 0, 1, starts with 1, includes 2, but not 3. Okay, so that's how the slices are going to work. Now, if we leave off the first value, it's okay. It assumes it to be 0. Okay, if we leave off the second value, it assumes it to be end of the line. Okay, so you can certainly do those slices. Okay, which turn out to be pretty useful. Okay, we also have the length function. Since this is a sequence of characters, we can use the length function on it. Okay, which will correctly report that we have 5 characters. Okay, which works. Okay, we can also tell if a string is in another string. Okay, so I can just print it out so we can see the idea here. So I can print if I want to know is LL in S1. Okay, when you do this, it gives me a true because LL is. Okay, so you can say something like, or you can put it in an if statement. So if LL in S1, then you can print whatever it is there. Okay. If you do that, it is there appears. Okay. You also have a not in. Okay. So in this case, it prints nothing. Okay. So we have in, not in. Okay. Note that those have to be in order. Okay. So if I would say, if in the first one, HL is in there. Okay. So it's not. H is and L is, but they're not there together. Okay. So in and not in are pretty important functions, pretty important structures for us to use when we're trying to see if something's in something else. Okay. There are also a lot of methods or functions that are associated with strings. Okay. And if you have the textbook on page 83, it's going to give us some. Okay. So there's a center function. So for the center function, okay, you can do this in a print. So we can print s1.center. Okay, and we want to give it how wide we want the whole thing to be. Okay, so let's say 20. Okay. So if you do that, you see, if you count, there are 10 spaces before, and then, well, no, that's not correct. There's 20 total evenly divided between before and after. Okay. You can see how many letters, how many of a certain letter appear in a string. Okay, so I can say s1.count. Okay, I want the number of L's in the string. Okay. Okay, it's going to give me, oh, is that an L or a 1? S1.count L. I think I gave it a 1. Now we get 2. Yep. Okay. Let you know how many of those that there are. Okay. Similar to the center, there's an L just and a right just. Okay, so what the L just will do is it will left justify the string, okay, with whatever the width you want it to be. Okay, let's say 30. Okay, so that will give you, and you can't see that, but if you had something else printed, it gives you that bit of space on the right. Same way that the R justify. If you run that, now you see it more clearly. That will go away. Go away. There we go. We now have the spaces before that. So this is 30. It puts it to the right of that. Okay. We also have the ability to do upper and lower case. Whenever you're asking the user for input or you're doing any kind of string comparison, it makes sense. That's function, I believe. So I think I have to do that. Yeah. Okay. So whenever you're doing any kind of comparison, you want to make sure you've converted the input to the same case. Okay, because if we want to print, just so we can see this is clear, is capital H equal to a little h, okay? And it turns out that it's not, okay? So make sure you keep that in mind, okay? So if you know, or if you want to find out where a character is inside of a string, okay? So let's say we have, if we want to see if it's there first, okay? So if O is in S1, okay, then we want to print out S1 dot index of O. Okay, else we can print dot in string. Okay. So this tells us that the O, first we know that it's found, okay, then it's in the fourth position, okay, so 0, 1, 2, 3, 4, which is correct, okay. If it were not there, just to see how that returns, it doesn't give you an error or anything, so I can just say print Z in that, get rid of this stuff. No, that's all I want. I want Z, sorry, proving the wrong thing. S1 dot index Z. Is that okay? Which is going to return the error substring not found. Okay. And later in the week, I think we're going to talk about exception handling, but you can't do that. So that's why I put it in an if to see if that worked. Okay. There's also a find function. The find function will return the index of the first occurrence. Okay. So if it doesn't find it, let me try this. Okay. So we do a find on Z. Okay. It returns a -1. It didn't find it. Okay. If we find it on L, there are 2 of those, but it's going to return 2 because 0, 1, 2 is the first occurrence of that. Okay. So there's also an R find. The R find is a search that starts from the other end. Okay. So if I do this, it tells me 3 because 0, 1, 2, 3 is the second one. Okay. Now, if there were more, it wouldn't get all of them. It would get either the first or the last, depending on how it's going. Okay. We also have the ability, which seems like it breaks immutability, but we're going to just say that it doesn't. Okay. That I can say that S1 dot replace. Okay, it's going to take the old. So let's say I'm going to replace the LL with an LL. Okay, and then print out the new value. Okay. That's what weird, didn't make a change there. Let me see if I print that. That may be what the issue was. I don't tend to use this command. So yeah, there we go. That apparently just, it doesn't make a permanent replacement. It's a temporary replacement. Okay. So I guess I could do a new variable. I could say something like S5 equals that, and print S5. Then those effects, if I get the number of parentheses correct, which I did not. Yeah, now that has the capital L's. Okay. So again, that's because of immutability. It doesn't break the immutability, which is good. Okay. So, I mean, I think that's it basically for the strings. There are other things that you can do. If you look online, there are lots of string functions you can do. There's some formatting things. There's converting to ASCII characters and back and all that kinds of stuff. Okay. But I think for now, to get us going, that's the basic idea. Oh, one other thing. Here's one other thing. You can also do something like for C in, let's say, S5. Then if I print C, again, since it's a sequence, it's going to go through and give me the letters sequentially, okay, of all the string. Okay, so, and that could be whatever it is. So have letters, numbers, whatever you've got. It will still continue to give all those independently. Okay, so you can go through each one. Okay, but again, you can't change the individual characters. Okay, the other thing that you do sometimes with strings that's worth noting is through concatenation. Okay, so if you want to build a string, okay, up. So let's see, you think you're done and you're not. Get rid of all this. Let's get rid of all this stuff. You can build strings, which is often how string programs work. Okay, so if you have like our A for alphabet is equal to, we've got A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. Good enough for me. Okay. Then if I want to create something like, I don't know, vowels. Vowels, I can start off with an empty string. Okay. And then I could do something like this. For C in A, to give us all the individual letters, okay, I can say if, and I would also, actually, let's define here A, E, I, O, U as that, okay, and then I want to get my answer, it's called answer, equal to 0, or to blank, and this wouldn't normally be an alphabet, this would be words. Okay, so let's do something else. You can have a better string here, like today is the next to last day of January, which is not true today, but it'll be true tomorrow. You get the idea. Okay. And then we can come in here, we can say if C is in V. Okay, so if C is a member of the vowels, I can let answer equal to answer plus, okay, C. Okay, C is going to be a string. I think this is going to work. I'm making this up. We'll see how it goes. Why can't I hit enter there? There we go. Okay, then we should be able to print answer. Okay, see if this works. Hey, we got something. Yeah. Okay, so that's okay. So that ignores the T, gets the O, gets the A, gets the I, gets the E, and so forth. Okay, so it's often the case if you're wanting a string that matches a certain criteria, you start blank and add it together. Okay, and again, this concatenation seems like it's going to violate immutability, but it doesn't, because what it's doing technically is creating a whole new string. Okay, so I've rambled on enough for this one. So hopefully this will give you an idea of strings. If you have any questions, make sure you let me know.